Hello, listeners. Welcome to the 9th episode of the Unlocking the Energy Trilemma podcast with our hosts Ravi Krishnan from the USA and Jose A. Martinez, JAM, from Europe. Today, Ravi and JAM speak with Kathryn Porter, an independent energy consultant with broad experience of the energy and finance sectors. Before launching What Logic, Kathryn held various energy structuring and hedging executive roles at Centrica, Societe Generale, EDF Trading, and at Barclays Capital. We talked today about grid interconnectors. Kathryn recently published a report titled Interconnectors and Their Impact on the Great Britain Electricity Market, so she is a perfect guest. Ravi, JAM, over to you.
Welcome, Kathryn, to the podcast of Unlocking the Energy Trilemma.
Thank you.
As we always ask to our guests, we ask them to bring us a figure which is relevant with the energy trilemma and with the topic we are talking today, which is basically grid interconnections. So what do you want to share with us?
So it's maybe less relevant to the topic of grid interconnections, but I think it's pretty important from the perspective of the trilemma. And that is that in the UK, every winter, between 4,000 and 6,000 people die as a result of being unable to heat their homes adequately. And that's a shocking statistic, but it's also one which is widely overlooked. And as we progress the energy transition, it's very easy to forget that many people already suffer from the effects of expensive energy. Alan Scorer, who runs the National Energy Action Organisation, said that the route to net zero runs through the homes of the poor. And I think that's something that's very important to keep in mind.
Wow.
Kathryn, let's dive directly into your recent report, and let's just to set the stage for the audience, because clearly you've addressed some very interesting aspects of the energy transition that apply not just to Great Britain, but on a global basis. So in your view, how do interconnects play a role in enhancing energy security and managing supply risks, especially during times of shortages or market volatility?
So I actually think they provide very little assistance in that area. I think the main way that interconnectors contribute is smoothing out price differentials during times of market comfort. But in times of system stress, I think it will be very difficult to rely on interconnectors. One of the reasons for that is that if you take a country like Britain, with the exception of two of our neighbours, all of the countries with whom we're connected are following the same wind-led energy transition strategy. And because we're geographically proximate, we have similar weather. The weather correlation between us and our neighbours, with the exception of Norway, is something between 45 and 65%. So if we have low wind conditions here, it's entirely possible there are low wind conditions in the connected market. And that will obviously mean that they don't have the surplus electricity to export to us. And we've seen an increase in energy nationalism since the Russian invasion of Ukraine. And this is feeding through into the way that interconnectors are being managed and treated. Norway has recently amended its Energy Act to give itself the right to restrict exports, not only in times of system stress, but in times of potential domestic shortages, which is quite a big step, and I think is the canary in the coal mine, if you like, when it comes to looking at interconnectors for energy security.
You've mentioned Norway. They have probably the lowest weather correlation with Britain of all the markets that Great Britain is connected to. I've heard that Norwegians understand that high power prices in their country are in some way related with cross-border power cables and interconnections. Is that a reason which is creating some kind of political reaction against interconnections?
Yes, very much. A couple of years ago, Norway opened big interconnections with both Britain and Germany. And at the same time, in that same year that those interconnectors opened, they experienced 20-year reservoir lows, and prices in NO2, which is the southern region where these interconnectors actually land, went up by a factor of 10 in the course of a year. the government ended up subsidizing end users by up to 90% of their energy bills. And this created a huge amount of tension in Norway. Although Norway has low weather correlation with Britain, the Norwegian system is based entirely on hydro, and there's very little pumping capability. This is something that many people outside Norway don't understand. So once the water is used, it's gone. It's gone completely until it rains again, until there's more snow melt. So it can very much be the case that by using that water to generate electricity to export, you're denying it to Norwegian consumers in future months. And this has become quite an area of contention. So not only have they amended their Energy Act to allow themselves to restrict exports, there's also a debate going on about whether they should renew the Skagerrak interconnectors with Denmark, two of which are coming close to the end of their lives in the next couple of years.
We have a wide variety of viewers, and just to help people from various markets facing various energy transition pressures, can you explain to us how, and from a Great Britain perspective, how the increasing reliance on intermittent renewable energy such as wind heighten the vulnerability of the Great Britain power system, particularly during prolonged wind lulls and period of high demand?
Yes, it's making us very vulnerable. We've had periods where wind and solar contributed almost nothing, because in the winter you have very little contribution from solar. In Britain, it's negligible, and definitely none in the evening peak, because it's already nighttime by the time the evening peak happens in Britain in the winter. And so in those circumstances, we rely heavily on gas, on nuclear, and increasingly on interconnectors. But unfortunately, most of our nuclear fleet is due to close by the end of this decade. By 2030, we're on track to have only one nuclear power station open, Sizewell B. And of course, Sizewell B cannot run indefinitely without maintenance. So on the current schedule, we will have periods of zero nuclear.
Oh, that's very different from what's going on in the US. As you may have recognized in the past year or so, there's been a resurgence and support for nuclear across party lines in the US. So that's interesting to know that in the US, for example, nuclear still is a big percentage of the system load, system generations. It is an integral part of the energy transition here in the US, but that's very different.
Well, but I think that's a relatively recent change in the US. The trend was towards closing nuclear power stations, and I think after Palisades and Indian Point closed, there was a bit of a change of heart, partly because some regions saw their carbon emissions go up quite significantly when they closed nuclear, but also you're seeing quite a lot of additional demand coming on the system from AI in particular. And so a lot of this is being driven by, in the US, is being driven by tech companies. Microsoft has just signed up with Constellation for the reopening of 3 Mile Island Unit 1. And then you've got, obviously, Holtec is trying to reopen Palisades. Amazon just tried to sign a big deal for nuclear output. So the dynamic is quite different. We don't have that same tech industry here in Britain. And although we are building new nuclear, it's unclear whether the new government has the same commitment to nuclear that the outgoing government had. But without nuclear power, we don't have a hope of meeting net zero. You just are not going to be able to do it with intermittent renewables, particularly in a country like Britain, where solar just doesn't contribute during your peak demand times.
And you've mentioned wholesale markets, and I think in Europe we are having a problem with the volatility of the price of the electricity, and sometimes interconnections could have a kind of boomerang effect in terms that if I am a country producing a lot of energy and I have a wide interconnection with you, I can send a lot of very cheap or even at negative price renewable electricity at some moments, which is, let's say, producing an impact in your local pricing. So sometimes interconnections, sure, could have this hero and villain role.
No, absolutely. And this is one of the reasons that Norway has become much less interested in interconnection, because it pushed their prices up. Norwegian prices were very cheap previously. And it's interesting that Ofgem, the energy regulator here in Britain, recently rejected all but one of the new interconnection projects that were being proposed in the next round of the cap and floor regime. And its reasons for doing this were that within the lifetime of these projects, Britain is expected to become a net exporter. And when you're a net exporter of electricity, interconnection actually creates a consumer detriment. Prices for consumers go up. Now, Ofgem's of the opinion that the benefit that accrues to generators, if it were evenly spread through the market, would therefore offset that detriment. But it doesn't believe the market is sufficiently efficient to do that. And so it's rejected all but one of these projects on the grounds that it would create a consumer detriment in the scenario where Britain's a net exporter. Clearly, that is already the case for the countries that are exporting to Britain today. So we are relying on them not noticing that their consumers are experiencing a disbenefit from exporting to us. And at some point, those consumers may start to become exercised on this point and start creating a fuss and objecting to the fact that their electricity prices are higher because we in Britain and Germany and the Netherlands are exporting their generation capacity to other countries. We're failing to invest in our own domestic capacity, and we're doing that at the expense of countries which have made those investments.
Let's talk a little bit about DERs and the role of DERs that are playing across the grid. So are you seeing a lot of DER activity and behind the meter systems that are a big portion of the system load, such as your microgrids and rooftop solars, batteries, heat pumps, standalone battery storage? What is your view on that, and what are some of the trends that we are seeing in Great Britain?
So I think the answer is no, we're not seeing huge amounts of that. And one of the big reason is because of grid connection problems, and that's similar in the US. And in a lot of countries, in fact, our grid codes haven't kept pace with the way in which the market is changing. And so a lot of projects are just not able to get connections, or they're being given connection dates decades into the future, which is really delaying the rollout of these schemes. But the other challenge is that managing it's a related challenge, if you like, is managing the impact on the grid of those things is not trivial. I'm just today about to publish a new report into heat pumps, and one of the conclusions of that report is that we should be looking at hybrid heat pump solutions where gas is used in the periods of highest demand. Because, and this is really looking at what's the experience in the Netherlands, they've had a very successful program of promoting heat pumps. But that, combined with other factors, is now leading to very high levels of congestion on their electricity grids, to the extent that they actually are concerned of the possibility of domestic disconnection before the end of this decade in periods of high demand. So
just as a follow-up on that, are you expecting or experiencing a lot of grid oscillations and instabilities and system strength issues? Are there low inertia scenarios that you're experiencing within the grid?
So we definitely do in Scotland. There are issues with voltage harmonics in Scotland, particularly since the closure of Longanet. Scotland is now very heavily dependent on wind power, and that's creating challenges, both in terms of inability to transmit that down into the rest of Great Britain because of lack of power lines fundamentally, but also just because now the grid there is much less stable. And the system operator is having real problems managing those issues and even understanding how they're arising. This is a non-trivial challenge that they're experiencing. And I think we see this in other markets with a lot of distributed generation and inverter-based generation. The NEM in Australia is a great example, where it's not uncommon for them to curtail solar and run gas purely for grid stability reasons, because things like grid forming power electronics are just not where they need to be to manage grid stability. So you're still very much relying on conventional sources of inertia. Just a couple of days ago, there was a report about new flywheel projects here in Britain, again, to contribute to grid inertia. And National Grid and AMO in Australia have been at the forefront of trying to develop commercial solutions for procurement of inertia and reactive power and short circuit control in this new world where we have much less stable, more flighty grids as a result of inverter-based generation.
The best way to have a secure network is with rotating big machines, like in power plants, distributed energy resources, long-term energy storage are good solutions, interconnections could help, but at the end, power plants appear to be in the market or remain in the market for some time, and capacity markets are a way to compensate the impact of the intermittent renewables. In Great Britain, you have a mature capacity market. Do you think it is a good solution for power plants, or is just a temporary solution, and at the end, power plants will be out of the market because they are not profitable enough?
I don't think it's particularly an issue for power plants. I think the capacity market will be forced to deliver the economics required to keep them in the market. And what I think it's very bad for is consumers, because consumers now pay several times over for every megawatt. If you want to have renewable generation, you pay for the megawatt of renewable generation, and it still requires subsidies. And the most recent subsidy round was higher than the previous ones and higher than the current wholesale price. So you're still paying a premium to buy renewable generation. So that's the first thing. So you pay for your subsidy for your wind megawatts. But then it's not always windy. So then you have to pay another subsidy for your gas megawatts to back up the wind megawatts when it's not windy. Then when it's too windy, you have to pay more money to curtail your wind, because now they have a subsidy. If they're not running, they don't get their subsidy, and then you have to compensate them. But then also you have this issue that the wind is being built in places where you don't have good grid connections. So now your consumer has to pay extra money for the grid connections. And finally, because wind is intermittent in real time, it's become much harder and more expensive to balance the market. Our balancing costs have gone up by billions of pounds a year here in Britain, and the consumer has to pay for that as well. So instead of just paying your power plant, your conventional power plant, for its megawatts, and you get an awful lot of that other stuff for free, a lot of the balancing comes for free with your power plants, or at least your grid stability does. Now you're having to pay all these other things: capacity market, extra grid connections, extra balancing costs, all of this that you didn't have before. So the capacity market will do its job, but it will contribute to the high costs that consumers face when you move towards intermittent renewables.
So this transition challenge doesn't look like a very good economic solution.
No, and consumers are being lied to by policymakers because they latch onto this idea that the wind is free. Yes, the wind is free. You don't pay for the wind to turn your turbines, but you pay a lot to build the turbine. You pay it's so expensive to build that the market won't build it for you. You have to subsidize it. No, and this idea that, oh, it's free, it's really cheap. Nobody's going to give away the thing that they sell their product. And yet this whole notion about cheap renewables is fundamentally based on this idea that it's essentially free. And that's not, that should be obviously untrue. The absence of logic in that argument should be something that's fairly obvious to people, and for some reason it's not. So politicians peddle this false narrative that green energy in the form of wind and solar is somehow cheaper for consumers than gas. And it's just a lie. The all-in end use retail cost to consumers is higher when you have intermittent renewables. Now, the wholesale price might be lower, but the consumers don't pay the wholesale price. The consumers pay the wholesale price plus a whole load of other add-ons, including the capacity market, grid connection costs, balancing costs, and so on. So by the time you get to the bill that the consumer pays, which is the only metric they care about, it's very expensive. And so intermittent renewables is not the way to decarbonize an electricity grid in a country like Britain. The only way you're going to do it in anything close to an economic way is through nuclear.
So looking at the future, is the prospects of wind generation costs likely to decrease in the next 5 to 10 years? What's your view on that? Because obviously you have raised a lot of challenges associated with, for example, DERs and the future of grid stability as more renewables and DERs and fast-acting batteries and inverters and grid-forming inverters, etc., are added to the transmission and distribution system. And you also brought up the point about nuclear not being the fuel of choice and renewables having its challenges, especially wind. Do you really believe that utilities have all the tools that they need to safely manage the transition? And in your opinion, what needs to be done?
Okay, well, to answer the first part of your question, I don't think that renewables are going to get cheaper. We've seen prices going up recently, which is really reflecting the global increase in energy costs. But the other problem which is coming down the track is access to raw materials. We saw in the last couple of years, Panama closed a very big copper mine, and you need 15 tons of copper per megawatt of offshore wind. So that's an awful lot of copper. And it's not just Britain's offshore wind ambitions that need to be met, it's everyone else's as well. Not only did they close this copper mine, but South American countries are rejecting permits for new mines. So there's going to be a growing tension between countries that own the mineral resources and countries that want to access them. And you cannot force these mineral-rich countries to extract those minerals when the local environmental cost is as high as it is. In Chile, for example, where the huge resources of copper, also lithium, the ground is extremely rich in arsenic. So when you open a new mine, you blast, you explode that rock into the air, it puts a lot of arsenic in the air, and then people inhale that, and you have high instances of cancers in the regions around the mines. So this is not a trivial challenge, and it's also not enough on people's radar. But access to critical minerals is going to be a key constraint in the delivery of the energy transition. And in my opinion, it means that we won't see prices fall. If anything, prices will go up because demand will outstrip supply. The other part of your question was around whether utilities have the tools that they need. They do, at the moment they do, but if you allow conventional generation retirements to go too far, then they won't. And we're facing a big crisis here in Britain by the end of this decade. If we don't extend the lives of the advanced gas-cooled reactors, then we are quite likely to face capacity shortages in low wind conditions. And I've seen some people saying, oh, we're going to build 23 gigawatts more batteries. Typical batteries have a duration of around 4 hours at the moment. So we have days where there's no wind. So it doesn't matter how many, if you build 23 gigawatts, which will be very expensive, but they're not going to back up. They're not going to replace the 20 to 30 gigawatts of gas that we're currently using. And the Labour Party seems to think that by 2030, we're going to be net zero on the power grid. There is no way we can remove all of that gas in that amount of time. And you're not going to do it with 23 gigawatts of batteries. You're not going to do it with 15 to 16 gigawatts of interconnection. The only way you can do it is with more nuclear, but you can't build more nuclear in that time frame. So if we look at energy policy in Britain, it's completely incoherent, and there's absolutely no way that utilities or grid operators can deliver on those goals. We'll be lucky to keep the lights on without demand curtailment. And I suspect if we don't build more gas power stations in the next couple of years, we'll be left with no option other than to curtail industrial demand and even manage consumer demand, domestic demand, in low wind conditions towards the end of this decade. And the economic and social harms that come with that will be significant.
I think this is a cold jar of reality, and trying to close in a positive mood. I would ask you, Kathryn, to close this episode. If you had a magic wand, what would you ask? What would you try to do to unlock this challenging energy trilemma?
Okay, so my magic wand would be around nuclear. Right now, the main leader in the Western world for nuclear development is KEPCO, So I would sign a contract with KEPCO to build 5 or 6 APR 1400s here in Britain. I would wave my magic wand to force our regulators to take a more pragmatic view. The APR 1400 doesn't have design certification here in Britain, but it does in the US. And I think there's the European version that's certified. So in my ideal world, our regulators would take comfort from trusted country regulators in terms of design certification, fast track that process and get these reactors built, because the harms of not doing it far outweigh the potential harms of doing it. And this is not a Mickey Mouse operator. KEPCO's successfully delivered 8 of these reactors in a short period of time, relatively on budget. If they can do it in South Korea and in UAE, they can do it here. And that's what I think we need.
You're talking Korea Electric Power Company, KEPCO.
Correct.
Is that
yes.
right? Okay. All right. Excellent.
It's
And I have no affiliations with KEPCO, by the way. It's just, to say, so I don't have some massive conflict of interest. It's just that you should do what works.
Yeah, I understand. Yeah.
And this is what works right now. So we should do it.
Definitively some controversial requests. If you compare with the trend of the, let's say, some politicians and countries and governments are moving to. So let's hope you are right and the magic wand works and we can fix the problem. Kathryn, thank you very much indeed for all your contributions, and we'll keep on listening to you and reading your reports.
Thank you.
Thank you very much.
We hope you liked this conversation. Follow us on LinkedIn or subscribe for free to the podcast on the platform of your choice, Spotify, Amazon, YouTube, or Apple. Because in the next episode, Ravi and JAM will speak with another industry expert who will help us to unlock the energy trilemma.